Welcome to the Explainer. So look, if you're using an AI coding assistant right now, you already know they're incredibly powerful. But let's just be totally real for a second. You also know they can be incredibly frustrating. Today, we're going to fix that. We're looking at how you can make your AI coding assistant 10 times more reliable. And we're doing it by applying 4 brilliantly simple foundational principles originally shared by Kaparthys. By the time you wrap up here, you'll know exactly how to turn your AI from this chaotic code generator into a highly predictable, rock-solid engineering partner.
Okay, let's dive into this. Because it really does feel like magic when it works, right? But you absolutely know the pain when it doesn't. You ask for a quick refactor, and suddenly you're spending half your time wrestling with the tool. You're reverting weird changes and basically fighting the AI instead of actually working with it to ship your product. It's a totally universal frustration, but the really good news? It's completely solvable.
So here's our roadmap for this explainer. 1. The AI coding problem. 2. 4 core principles. 3. Daily workflow impact. 4. Claude implementation setup. 5. Porting to Codex. And finally, number 6, caution over speed.
All right, section 1, the AI coding problem and exactly why these models fail.
It really boils down to 3 main frustrations. First off, these models, they're chronic guessers. When they hit a point of ambiguity, instead of stopping to ask you a question, they just make a silent assumption and keep right on coding, driving you straight into a dead end. Second is over-engineering. I mean, we've all been there, right? You ask for a simple helper function or a basic regex, and what you get back is this 1,000-line, over-abstracted monster designed for Google-scale traffic. It's too much. And third, the dreaded drive-by edits. The AI is supposed to be fixing one specific bug, but it decides to helpfully refactor some totally unrelated code on the side, which just creates a massive headache when it's time to review the pull request.
Moving on to section 2, 4 core principles. Let's look at Kaparthys solutions. The first principle is think before coding. Honestly, this is the ultimate cure for the guessing problem. It forces the AI to stop, state its assumptions explicitly, and ask for clarification whenever it encounters missing context. So, if a request could mean 2 different things, the AI is no longer allowed to just pick one and run with it. This single rule transforms the AI from a silent, unpredictable machine into a genuine, collaborative partner that actually pauses when it's confused. Next up is simplicity first, which is your direct antidote to all that over-engineering. This principle demands the absolute smallest, clearest implementation that fits the surrounding code base. It strictly prohibits speculative future-proofing or unrequested abstractions. The guiding question here is super simple. Would a senior developer look at this code and think it's unnecessarily complicated? If the answer is yes, the AI has to go back to the drawing board and simplify it, period. Our third principle is surgical changes. This rule dictates that the AI must act like a good citizen in your codebase. It's only allowed to touch the files strictly necessary for the task, and it actually has to justify every single line in a diff. This completely neutralizes those annoying drive-by edits. It stops the AI from cleaning up unrelated dead code or refactoring adjacent logic just because, it happened to be in the neighborhood. The result? Completely clean, hyper-focused pull requests. Now, what's really interesting about this slide is this fourth principle, goal-driven execution. This one is the ultimate game changer for AI reliability. It requires the AI to define verifiable success criteria, like writing a unit test, a reproduction script, or an acceptance check before it declares a job done. It's all about observable completion, rather than just throwing vague instructions at it and hoping for the best. To really anchor this conceptual shift, let's look at Kaparthys' exact phrasing. The flawed approach is giving the AI a recipe, like telling it exactly what steps to take. But the Kaparthys approach, it's giving it a finish line. Think about it. These AI models are incredibly good at iterating and problem solving, provided they know exactly what goal they need to hit. If you give them a clear finish line to reach, they will loop and iterate until they actually cross it. All right, section 3, daily workflow impact. How does this look in real-world coding? Well, you'll see an immediate shift in behavior. For bug fixes, the AI will now identify or write a failing test or reproduction first, and then make it pass, guaranteeing a regression test every single time. For new features, it naturally keeps APIs narrow and actively resists building broader, unnecessary abstractions. And for code reviews, you get tight, predictable diffs with 0 surprise edits, which honestly is going to save you a massive amount of review time. Section 4, Claude implementation setup. Let's get into the actual implementation. Let's move to and see how this builds in a Claude environment. If you're using the Claude Code CLI, it's literally just a couple of commands. Step 1, you add the marketplace. Step 2, install the Kaparthys Guidelines plugin. Doing this makes the skills active globally across all your projects.
But hey, if you prefer to have these rules version controlled right inside your specific project repo, you have an alternative. Step 3 shows you can simply run a curl command to download a file called claude.md right into your project's root directory. It's incredibly straightforward.
Section 5. Porting to Codex, making this platform agnostic. To understand the migration here, we really just need to juxtapose the tool architectures. Where Claude relies on that clud.md file for always-on repository guidance, the direct equivalent in Codex is agents.md. The overall structure translates almost one-to-one, right down to the plugin manifest files if you eventually decide you want to package it up for distribution. For the exact first pull request to port this to Codex, you want to keep it small and local. Step 1. Create that agents.md file at the root of your repo containing those 4 core rules we just talked about. Step 2. Expose the skill path by creating a symlink to .agent/skills. This allows Codex's local discovery to find it without you having to deal with complex plugin packaging right out of the gate. And step 3, make sure you update your README and your examples documentation with validation prompts so your whole team knows exactly how to use it. Speaking of validation, once you've actually set up agents.md, you need to prove the new behaviors are working. As a maintainer, you should run these crucial checks. First, explicitly ask Codex to list its loaded instructions just to ensure it's actually reading agents.md. Next, try triggering the skill explicitly with $Kaparthys guidelines. And finally, the ultimate test. Give it a vague, ambiguous coding request and confirm that it pauses and asks you clarifying questions instead of just blindly guessing. Section 6. Caution over speed. Let's talk about the trade-off. So, the crucial point here is understanding the trade-off. These guidelines deliberately enforce caution. They force the AI to think, to verify, and to justify its work. And that is absolutely brilliant for complex, risky, or user-facing feature development. But if you just need to fix a one-line typo or add a missing semicolon, this strict workflow might be total overkill. You don't need a surgical team to apply a Band-Aid, right? You have to use your judgment as an engineer. The goal is rock-solid reliability on the work that actually matters, not artificially slowing down your simplest, everyday fixes. Which leaves us with one final thought. We've seen exactly why AI fails, we've broken down Kaparthys' 4 brilliant fixes, and we've walked through the practical setup for both Claude and Codex. The tools to fix the frustration are literally just a text file away. So, are you ready to stop fighting with your AI assistant and finally turn it into the reliable coding partner it was always meant to be? Implement these principles in your next session, test them out, and experience the difference for yourself. Thanks for joining me for this explainer, and happy coding.